My name is Clarice, and I'll be doing the introduction to AC, synchronous, and induction motors. First of all, which motors are more powerful, AC or DC? AC motors are generally more powerful as they can produce a higher torque by using a more powerful current. However, DC motors are typically more efficient and make better use of their input energy. Both AC and DC motors come in a variety of sizes and strengths that can meet the industry's requirement. AC stands for alternating current, whereas DC stands for direct current. Here are a few examples of AC motors: induction motors, linear motors, and synchronous motors. AC motors can also include variable frequency drives to control the torque and speed, while DC motors are available in self-excited and separately excited type models. What is an AC synchronous motor? A synchronous electric motor is an AC motor in which, at steady state, the rotation of the shaft is synchronized with the frequency of the supply current. The rotation of period is exactly equal to an integral number of AC cycles. What is an induction motor? And this is the focus of our topic. An induction motor or a synchronous motor is an electric AC motor in which the electric current in the rotor needed to produce torque is obtained by electromagnetic induction from the magnetic field of the stator winding.
Hi and Assalamualaikum. My name is Wan Muhammad Syahrin from BETS1/1. In this video, I am going to briefly explain about the working principle of three-phase induction motor. So basically, a three-phase induction motor is a machine which is constructed to work on the three-phase supply, also known as the asynchronous, and it is working depending on the principle of revolving magnetic field. And as we can see here, this is a cut view photo of a three-phase induction motor, and there are two major parts in this machine, which is the stator and the rotor. In simple manner, the principle of operation are a rotating magnetic field set up in the stator when a three-phase supply is given. The stationary rotor cut the revolving field, and due to the electromagnetic induction, an electromagnetic field is induced in the rotor conductor. As the conductor is short-circuited, then current flows through them. It becomes a current-carrying conductor in magnetic field and start rotating.
Hello everyone, my name is Zulazik Adimi Beputra, and today I would like to explain about the operation of AC synchronous motor. As the name suggests, synchronous motors are capable of running at constant speed irrespective of the load acting on them. They are machines with high efficiency and mainly used in high application. The constant speed characteristic is achieved by interaction between a constant and rotating magnetic field. Rotor of synchronous motor produce a constant magnetic field and stator produce revolving magnetic fields. The field oil stator is excited by a three-phase AC supply. This will produce a revolving magnetic field which rotates at synchronous speed. Rotor is excited by a DC power supply, so it acts like a permanent magnet. Interaction of rotor and RMF is interesting. Assume you are giving an initial rotation to the rotor with same direction of RMF. You can see the opposite poles of RMF and rotor will attract each other and they will get locked magnetically. This means that rotor will rotate the same speed of RMF and rotor will rotate at synchronous speed. Synchronous speed can be easily derived as follows. This means that if one has got control over frequency of the electricity, speed of synchronous motor can be very accurately controlled.
And now I want to explain about advantage of AC synchronous motor and AC induction motor. This is advantage AC synchronous motor. First, efficiency. More efficient than induction machine. Synchronous reluctance motor have no rotor losses. Then, power factor. Flexible power factor, lagging unity. Then, power. Synchronous motor are best suited for very high power at lower speed. Then, speed. Speed is constant at any load. Next, speed is not dependent on the load. Load. High speed operation help to eliminate power transmission elements such as gearbox. Switch reluctance. Switch reluctance synchronous motor produce 100% torque at stall indefinitely. Then, AC induction motor. Efficiency. Used when huge power at the highest efficiency is required. Power. Power and induction motor is singly excited. AC power is supplied to starter motor. Starter only. Speed. Induction motor are best suited for high speed. Torque. 3-phase induction motor have high starting torque. Maximum slip at maximum torque at 0 speed. Starting. 3-phase induction motor are self-starting. Maintenance, minimal or no maintenance. Lesser part to maintain.
I will continue with disadvantage of AC synchronous motor compared to induction motor. Disadvantage of AC induction motor. 3-phase induction motor require 3 power supply lines. Speed. Motor speed is always lesser than the synchronous speed. It doesn't rotate at the same frequency as the alternative drive current. Single-phase induction motor are not self-starting. Induction motor has lower efficiency compared to synchronous motor. With disadvantage of AC synchronous motor. Power is doubly excited. Starter is supplied with AC power and rotor is supplied with DC source. Speed. To achieve variable speed, it needs variable frequency drive to adjust supply frequency. AC synchronous motor has no self-starting. It costs more expensive than induction motor but with the same power rating. Efficiency. When operated at a high current or high temperature, the permanent magnets are subject to demagnetization.
I'm going to explain about an example of the application of an induction motor. We mostly use induction motor in fans, domestic-wise and industry-wise. Why don't we use synchronous motor rather than induction motor? But synchronous motor isn't very practical when used domestically or industry-wise, just because synchronous motor they need complex starting and closing strategy, and basically it's just very heavy in size. Not only that, disadvantage for a synchronous motor is that we can't obtain a variable speed by using the synchronous motor, but using the induction motor, by changing its frequency of the AC supply or the number of coils, we are able to use variable speed for the fan.
Hello, my name is Muhammad Farhan bin Praigno. Today I would like to make a conclusion about synchronous and induction motors. From above, we have concluded that synchronous motor started on induction principle. The damper winding acts like the squirrel cage rotor producing the starting torque. In the starting operation of a induction motor, the field is kept shorted while the starter is switched on the 3-phase AC supply. As the motor reduces close the synchronous speed, the field is energized from DC supply. The rotor now gets synchronized automatically because coupling of rotor with starter magnetic field. A high starting torque synchronous motor is combination of synchronous and slip ring induction motor into one machine. Synchronous motor have the unique ability to run at different power vectors. Thank you.